Hi guys, welcome back to Think Tank Online Learning. So in this video I want to talk about finding volumes using spherical coordinates and cylindrical coordinates. Okay, so I'm going to first explain what is spherical coordinates and what is cylindrical coordinates, then after that we're going to solve some problems. Okay, so in this video we're going to talk about what we mean as spherical coordinates and cylindrical coordinates. Okay, so first of all I'm going to start with cylindrical coordinates. Okay, so the only thing I'm more concerned about is finding the limits, evaluating the limits in a given a problem, okay, using cylindrical coordinates. Okay, so I'm going to start by a simple equation of a circle. Okay, so this is the equation of a circle, but when you are in space it becomes the equation of a cylinder. Okay, since the cylinder is just a collection of circles. Okay, so now given this problem, we know radius is equal to the square root of 1. So that means radius is equal to 1. Since the equation of a circle is in the form x squared plus y squared is equal to 1. Okay. So if I was to sketch this, I will have my circle. Okay. So the center of this circle is the origin. Okay. So now when we're evaluating limits in cylindrical coordinates, the only thing we're concerned about, or just concerned about the angle, which is theta, and the radius. Okay. So I'm going to start with theta, the limits for theta. Then I'll go to the limits for the radius. Okay. Now for theta, I'm starting at this point in the first quadrant. Okay, I'm going in a counterclockwise direction. Okay, in this direction. So from here to here it's pi upon 2, or just 90 degrees. From here to here it's pi 180 degrees. From here it's 3 pi upon 2, or 270. Up to here we now have a full circle. So theta ranges from 0 to 360, or 2 pi since we're using radians. Okay, then the radius. Okay, yes, since the radius is 1, so you're going to have 1. It's not different. Our radius do not range from -1 to 1, but it ranges from the center to any point on circumference. So here the radius ranges from 0 to 1. Okay, so this is the cylindrical coordinates when are given a simple circle, but most of the time they'll give you some bounds. Okay, let's say given x squared plus y squared is equal to 4. Then are given a condition, they'll just say, let's say y is greater than or equal to 0. Okay, so first of all, we have to identify a radius. Radius equals to root 4. Okay, and this is equal to 2. So I'm going to say this is number 1 here, number 2 here. Okay, number 2 here. Okay, so I'm going to draw this circle. Okay, the origin is still my center. Okay, y, x, this is my circle. Okay, it doesn't look good, but at least you know what I'm trying to do. Okay, so I gave -2 here, I gave 2 here. Okay, but let's look what we're given if a condition y is greater than 0. Okay, so we don't need y here. Okay, so we are shading the unwanted region. Another way, we could have just drawn a semicircle. Okay, so this is what we're doing right now. So I'm going to put my ranges for theta and for r. Okay, so for theta we're starting here. Okay, 0, pi upon 2 up to pi. We no longer need this region, so theta starts from 0 to 2 pi. Okay, it's not from 0 to 2 pi, but it's now from 0 to pi. Okay, since we do not want this region. Okay, but the radius, okay, so the radius from this point to this point, this point, this point is not affected. So it's from 0 to 2. Okay, so each and every time I'm given some bound somewhat, just know that the radius is not affected. Okay, so let's say we're given another equation, x squared plus y squared is equal to 2, and they give you, let's say they say y is less than 0, then they'll say that x is greater than 0 or equal to 0. Okay, so now first of all, the radius, I'm given a radius like this, just know the radius is still the square root of a. In this case a is 2, so that means the radius is root 2. Okay, so I'm going to draw my third circle here, y and x here. Okay, still, since the origin is still a center, we have a circle here. Okay, now let's look at this condition. Okay, by the way, this is 2, -2. Okay, let us look at the condition. Okay, y is lesser than 0. Okay, so we don't need y here. Okay, but x is greater than 0. Okay, so x is negative in this region. Okay, I'm going to use a different color. Okay, so x is negative in this region. Okay, so now as you can see, the portion which you are now interested in, we're just interested in this portion. Let's say y, x. Okay, in this portion, the fourth quadrant. Okay, so let us write our limits. Theta. Okay, so for theta now, we always measure in counterclockwise direction. We don't change. Okay, so for theta, it's now from here to here. We don't have anything here to here. We don't have anything. But we're starting from what? From 3 pi upon 2 up to 2 pi. Okay, and you say that the radius is not affected. Okay, the radius won't be affected. So radius from 0 to root 2. Okay, so this is what you may see. Sometimes we may given the bounds for y, the bounds for x, and the bounds for z. Okay, so just okay. In some cases, you may be given 2 circles and want to calculate the region. Okay, I'm going to write this in red. Let's say you are given a region. This is first circle, x squared plus y squared is equal to 4. Then we have another circle, x squared plus y squared is equal to 2. Okay, then in both regions, you're given a condition that x is greater than, let's say x greater than 0. Okay, since they said x greater than 1 here, I want to just try new things. Okay, and they're saying y is greater than 0. Okay, now we want to find, let's say I want to find the area between this circle. Okay, so I'm going to do it here. Okay, so first of all, we draw our xy plane, y, x. Okay, then the first circle is the bigger one. It has got a radius of 2, and the second circle, smaller one, is a radius of root 2. Okay, let me just write here root 2 and 2. Okay, so I'm going to find the area. So first of all, let's consider our bounds. X is less than 0. Okay, so that means we don't need x here. Okay, we don't need x here. Okay, but y is also greater than 0, so that means we don't need y here. Okay, so we're only concerned about this portion. Okay, I'm going to draw this portion here. Okay, y, x. Okay, so just concerned about this portion, and I say this is root 2 and this is 2. Okay, now it's time for us to write our limits. Okay, our limits is for theta. Okay, for theta from the first quadrant, we're going to start here, and this is pi upon 2 up to here, up to pi. Okay, now for r, okay, you have to pay attention here. This is the region we're interested in. R is not starting from 0, but from the smaller circle, which is root 2, up to a bigger circle, which is a radius of 2. Okay, so this is what we do in cylindrical coordinates. Is simple. Okay, so now in cylindrical coordinates, the z-axis doesn't change, the z-coordinate doesn't change. Okay, so let's say the other thing you should know is x is equals to r cos theta, y equals to r sin theta. Okay, so now if we say x squared plus y squared, we're going to get r squared cos squared theta plus r squared sin squared theta, and that is equal to r squared. So that means r is equal to the square root of x squared plus y squared. Okay, so each and every time we see x squared plus y squared, okay, just think of r. Okay, so cylindrical coordinates are just like simplifying the work. Okay, and instead of writing dy dx in cylindrical coordinates, we're going to write r d theta. Okay, r is our Jacobian, but we're not proving it in this video. Okay, so let's say you're in triple integral. We have dz, dy, dx. I have said that z is not changing. Okay, z is not changing. What is just changing is dy, is y and x. So dz will remain, but instead of writing dy dx, we're going to write r dr d theta. Okay, so this is what you need to know. Okay, then spherical coordinates. Okay, we normally use spherical coordinates when we're given a sphere or a problem that involves a sphere. We have theta. Okay, theta is just the same as in cylindrical coordinates. It's just the angle we rotate around the z-axis to cover the required region. Okay, and we have rho. Rho is just same as the radius. Okay, it's just the radius of sphere. Okay, we're going to call it rho instead of writing it r. Then we have a new term phi. Okay, phi is the angle from the positive z-axis that will rotate through to cover the required region. Okay, then other thing you need to know is that x, we're going to say x is going to be replaced by rho sine phi cos theta. Okay, then we have y is rho sine phi sine theta. Okay, and the z now changes, not the same like cylindrical coordinates. So z is equal to rho cos phi. Okay, and in most of the time you won't be given phi, you won't be given theta. Okay, so what we're going to use, you can use these equations, just equate one, you can equate these equations. You can find phi using those equations. Okay, then we have, instead of writing dz, since we're in volumes, dy dx, we're now writing rho squared sine phi. Okay, then write d rho for the radius, the theta, the phi or the theta, phi for the angle, and the theta for the angle. Okay, we said phi and theta, we see the differences, we solve some problems. Okay, so this is what you need to know in spherical coordinates. Each and every time I given a sphere, you use spherical coordinates, you're going to obtain, your work is going to be easy. Okay, so we have our first problem. We're going to use cylindrical coordinates. Okay, so in this problem, the reason why I chose this problem, okay, is that you see you are given the want to find the volume of a paraboloid. Okay, but instead of given an equation that is z equals x squared plus y squared, in this case we're given y equals x squared plus z squared. Okay, so I want to show you how you can use cylindrical coordinates. Okay, so the first thing you have to do, I think you should try by all means to sketch, but if you don't know how to sketch, it's still good. Okay, so I'm going to sketch this. I'm going to sketch this surface. Okay, so this is going to be my z-axis, and this is going to be my y-axis, and this is going to be my x-axis. Okay, but right now know that this paraboloid, I'm given it in terms of y. So that means, what does it mean? It means now this paraboloid lies on the y-axis. Okay, so for the plane y equals to 4, just cool, I'm going to draw it. This is the plane y equals to 4. Okay, the reason I'm drawing the dotted line, I'm going to show you. Then for this paraboloid, I'm going to have something that looks like this. Okay, so this is the plane, the bound. Okay, so now I can draw my plane here. Okay, so this is the paraboloid I'm concerned about. Okay, but I've said most of the cases be given the question of the paraboloid z equals to. Okay, so now I'm going to treat y as z, just simple. Okay, so we know x, we said y equals to z. Okay, so now I want to evaluate the limits. Okay, and we said z is not changing, so in this case z is y, so I'm going to write the limits for y here. Okay, what is the lower bound of y? Okay, so if you draw this, you're going to see the lower bound is just going to be this bound, and the upper bound is going to be 4. that is going to be good. Okay, then the lower bound is going to be, okay, let's see if we say y equals to 0 here. Okay, that is lower bound. What about here? We don't know. We're going to use the equation x squared plus c squared. Okay, but let's say you don't know how to draw. What are you going to do in an examination? Okay, just think of a number which is less than this one, or which is less than the half of this one. I'm going to think of 1. Okay, so that means when x equals to 1 is equals to 1, y equals to 4, then here y equals to b is going to be 1 plus 1, and that means y equals to 2. So automatically this becomes the lower bound. Okay, then now I'm going to z explain. Okay, and I'm saying most of the time you'll be given z inside the formula here. So now I'm going to draw the z explain. The z explain is same as drawing the y explain, but since y is the circular formula, I'm not going to say yx, I'm going to say zx. Okay, what is happening? Okay, so now you don't know what is going on, but I think in method you get close. Okay, you have y here, you have y here. What happens if say y1 is equals to y2? Let's solve them simultaneously. 4 is equals to x squared plus c squared. Okay, you see this is the shadow. Okay, so this is a question of a circle. So I'm going to have 2 to the power 2 is equals to x squared plus z squared. So automatically now we have a clue. Okay, so you can just draw a circle here. Okay, you may not be able to draw this parabola, but a circle, everybody should be able to draw a circle. The center is the origin, the radius is 2. Okay, now let's evaluate the limits. I think we've done that. Okay, theta, a full circle, from 0 to 2 pi. Okay, then the radius r from 0 to 2. And guess what? We're good. Okay, now just time for us to evaluate our triple integral. Okay, but I said this is z, but in this case, I'm just treating it as y. Okay, so that means what is the lower bound of z? Okay, you just look, it's too hard. Okay, so I'm going to, I said r is equals to x squared plus y squared. So in this case, r squared is equal to x squared plus z squared. So that means the lower bound of z, I can write it as r squared y to 4. Okay, see, this is how cylindrical coordinates is your things. Okay, so now let's perform our triple integral. I'm going to write here volume 0 to 2 pi. This is for the angle. 0 to 2 for radius. 0, okay, it's r squared for the z, r squared 4, and the said dy, in this case it's dy is not changing, but said y same as z. Then for dz dx is r dr d theta. Okay, so if we integrate back to z, okay, the other thing you should note, okay, I think I used to make mistake here. Okay, do not forget this r. If you forget this r, everything, your answer will be affected. Okay, so here from 0 to 2 pi. Okay, 0 to 2. If we integrate here, you're just going to get y. The limits r squared 4 r dr d theta. Okay, now if we plug in the limits upper bound minus lower bound, we're going to say from 0 to 2 pi, 0 to 2, and we're going to get 4 minus r squared times this r dr the theta. Okay, so from 0 to 2 pi. So before doing anything, we're going to expand here. We're going to get 4r minus r to the power 3 dr d theta. Now I think if we integrate, we're going to get 4r to the power 2 over r to the power 4 over 4 from 0 to 2 to theta. Okay, now if you see our bound minus lower bound, here we can just say 2 times 2 divided by 2, so we're going to get 4. Okay, 2 times 2, that is going to be 4. We're going to just say 2 into 1, we're going to get 2, so you're going to get 8. Okay, so that means we're going to, from 0 to 2 pi, you're going to get 8 minus, okay, what about here? We said 2 to the power, if we say 2 to the power 4, okay, that is 16. 16 divided by 4, we're going to get 4 to theta. Okay, so from 0 to 2 pi, we're and we have 4 the theta, and if we integrate respect to theta, we're going to get 4 theta. All our bounds from 0 to 2 pi. So that means we're going to have 8 pi is our answer. Okay, so let's say so let's say you find a mistake in my video, especially in the grading, sometimes may omit a number. Okay, just let me know in the comment section. Okay, now, so this was it for this problem. We're moving to the next problem. Okay, so for this problem, okay, find the volume of the solid bounded by the plane z equals to 0 and the paraboloid. Okay, so I'm given a paraboloid. Okay, so now instead of drawing it like this, see if a negative, so I'm going to draw it like this. Okay, so if you don't know how to draw, okay, now you can just say, okay, let's say you don't know how to draw, what does this plane look like? Okay, I know in 2D, drawing 2D, just simple. Okay, so what if we let y be equal to 0? Okay, so going to have z is equals to 1 minus x squared. Okay, let's draw it in the z x plane. Okay, so draw this in z x plane. Okay, you're going to see, I'm going to have something that looks like this. Okay, then you have z, this is going to be your upper one, is going to be upper limit. Okay, now what about when y equals to 0? We're going to have a plane here, let's say z y plane. Okay, you're going to have something that looks like this. Okay, so now we have a clue, since y and x are opposite. Okay, so you know you're going to have something, a circle like this. Okay, then you're going to draw something that looks like this. Okay, then from the y you're going to have something that looks like this. Okay, and now I think we have a claw. Okay, I think that's okay. So now what I'm going to draw is this paraboloid. Okay, so we're very good. Z is now our is the circular formula. Okay, so I'm going to draw my shape here. Okay, z equals to 0, that is the origin. Okay, so that means this paraboloid is going to be look like this. Okay, fine, and this point is 1, but I don't need that. Okay, so now or using cylindrical coordinates if I given a problem like this. Okay, so for cylindrical coordinates, I don't know, since we said we get our limits from the shadow of this shape. Okay, this is x, this is y. Okay, so for if we get our limits from the shadow, okay, what's going to be this shadow? But see, let's solve this equation simultaneously. Z1 is equals to Z2. Okay, so I'm going to have 1 minus x squared minus y squared is equals to 0. Luckily, we have a circle, you see, of radius 1. Okay, so we draw a circle here. This is a circle, y, x. Okay, so that means the radius is 1. So theta ranges from 0 to 2 pi. Okay, then radius r ranges from 0 to 1. Okay, so it's time to evaluate our triple integral. Then for z, okay, z, what is the lower bound and what is the upper bound? Okay, so if you're given z0, okay, just know the lower bound is 0. Okay, then the upper bound. Okay, but in some cases z may be the upper bound. Okay, so this case z0 is just what is the lower bound, so that means this is going to be the upper bound, 1 minus x squared minus y squared. Okay, so now I think if we write this, you're going to see we have 1 minus, okay, I'm going to write it in red here. This is same as saying 1 minus x squared plus y squared. Okay, and this is equal to 1 minus r squared. Okay, so the upper bound for z, you can write 1 minus r squared. Okay, so now let's compute our integral. Okay, triple integral, I'm going to say v 0 to 2 pi for the angle, 0 to 1 for the radius, then 0 to 1 minus r squared, that is the limit, the z, since z is not changing, r the theta. Okay, so now 0 to 2 pi 0 to 1. If we integrate respect to z, you're going to have z limits from 0 to 1 minus r squared to r to theta. Don't forget this r, okay? And if we do that, we're going to have 0 to 2 pi 0 to 1 of 1 minus r squared times r to theta. And if we expand, we're going to have 0 to 2 pi of 0 1 r minus r to the power 3 dr d theta. And if we integrate here, 0 to 2 pi, and if r squared over 2 minus r to the power 4 over 4 for limits 0 1 d theta. Okay, then what is going to happen here? Upper bound minus lower bound from 0 to 2 pi, you're going to have 1/2 minus 1 over 4 d theta. Okay, so if you integrate here, you're going to have 1/2 minus 1/4. I think that is equal to 1/4. Okay, we're going to have 1/4 theta. Our boundaries from 0 to 2 pi, and this is equal to 1/2 pi, or just pi upon 2. Okay, so this was it for this problem. Now going to the next problem. Okay, so this is another question on cylindrical coordinates. Okay, after that we go to spherical coordinates, and are going to combine shapes. So we have cones and spheres combined together, or a cylinder, cone, and sphere. Okay, so now given this problem, okay, find the volume of a solid that is inside a cylinder. Okay, and below c is equals to 2x squared plus 2y squared, and above the xy plane. Okay, so let me just try to sketch here. Okay, so say this is the z-axis, y and x-axis. Okay, so I know we have a cylinder, so I'm going to start with the cylinder. Okay, so this is the cylinder. Okay, but we have this shape. As you can see, it's a paraboloid. Okay, so now think these are the centers. Okay, z0, but x equals to 2 and y equals to 2. So here's something that looks like this. Okay, but the only thing I'm concerned about is just the shadow, and we are very fortunate that we don't see the shadow is going to be a circle. Okay, since we have a cylinder. Okay, so now we're going to have our y x plane. Okay, so now, okay, I think everybody knows now that theta ranges from 0 to 2 pi, and r ranges from 0 to, okay, we don't know what r ranges from 0 to. Okay, so yeah, if you look at this equation, this is just the equation of a circle, and we said r is root 16. Okay, that means r ranges from 0 to 4. Okay, and what else do we have? This thing is above the xy plane. Okay, so that means we're going to set up our triple integral. But what is the lower bound of z, and what is the upper bound of z? Okay, since this thing is above the xy plane, so that means the lower bound of z is going to be 0, then the upper bound is going to be this equation. So I'm going to write it as 2x squared plus y squared. Okay, then I know this is equal to r squared. Okay, so now the volume is going to be 0 to 2 pi for the angle, 0 to 4 for the radius, 0 to 2 r squared, since this is same as r squared, for what? For the z limits. Then I'm going to say dz r dr d theta. Okay, let's integrate respect to z first. I'm going to have 0 to 2 pi, 0 to 4, and I'm going to have z limits for z 0 to 2r squared r dr theta. Don't forget this r. Okay, and if we do that, I'm going to have 0 to 2 pi, and upper bound minus lower bound here, I'm going to have 2r squared r dr d theta. Okay, and if you solve there, I'm going to have 0 to 2 pi, 0 to 4. Okay, and we're going to have 2r cubed dr to theta. Okay, let me change the marker, it's not becoming very faint. Okay, so if we integrate here, we're going to have 0 to 2 pi 2 r to the power 4 over 4, and we have bounds 0 to 4 to theta. Okay, 2 into 2 1 2 into 2 2. Okay, so here we have 4 to the power 4, and that will give us 256. So we're going to have 0 2 pi, and we have 256 to theta, and if integrate with respect to theta, we're going to have 256 theta. Our boundaries from 0 to 2 pi, and if we're going to multiply 256, okay, but here we have 2, I should have divided 256 by 2 here, so it's 256 divided by 2, and I'm going to multiply that answer by 2, and I'm going to have 256 pi. That is going to be our answer. Okay, so now this problem looks like a very hard problem, but cylindrical coordinates, everything will become easy. My next problem is going to be on spherical coordinates. Okay, so we're given a problem. Find the volume of x squared plus y squared plus z squared is equals to 16 with z equals to 0. Okay, so we're given a sphere. Okay, in this case, okay, look, when we talked about cylindrical coordinates, we said to be given the bounds for y and x. In this case, we're given the bounds for c. Okay, so what I'm going to do, I'm going to draw two diagrams here. Okay, so this is the first diagram. Okay, z, y, x. Okay, so I'm going to draw a sphere. Okay, so a sphere, this is going to be my sphere. Okay, so this is going to be the center. Okay, I'll have a sphere that looks like this. Okay, so this is a sphere. Okay, but what are we given? We're given a condition here: z is equals to 0. So that means we don't need this portion. Okay, the lower portion. So that means I'm going to have a sphere that looks like this. Okay, z, y, x. Okay, so now my sphere will look like this. Okay, so there's something that we didn't mention when we talked about spherical coordinates. Okay, so phi, we said phi. Okay, so for now, phi ranges from 0 to pi. Okay, and phi, we said phi is the angle that rotates from the z positive z-axis through the region. Okay, so here this is the positive z-axis and this is the negative. So if we rotate here, okay, we rotate here, rotate here, rotate here, up to here. Okay, so we're good. That means our phi ranges from 0 to pi upon 2 in this problem. Okay, so you see, this is it's the same sphere. We're going to find it using integral, then we're going to find it using formulas, the general formula. Okay, so what is rho? Okay, rho is equal to 4. Rho ranges from 0 to 4. Since we said r, this is rho squared. Okay, now what about theta? Okay, theta said this is the angle that rotates right round the z-axis to cover the region. So as you can see, theta is equal to ranges from 0 to 2 pi. Okay, 0 to 2 pi. Okay, and we don't have radius. Okay, in spherical coordinates don't have radius. It just said it's rho. Okay, so this is for theta. The distance will rotate right around the axis. Okay, but for phi, this is the distance that rotates through the positive z-axis to cover the region. Okay, so let's say if it was a full sphere. Okay, so phi was going to be 0 to pi. Okay, so now we said our triple integral volume is equals to 0 to 2 pi, that is for the angle, 0 to pi upon 2, that is for phi. Okay, then 0 to 4, that is for rho, our Jacobian phi squared sine phi. Okay, to rho to phi to theta. Okay, so now let's integrate respect to rho first. 0 to 2 pi, 0 to pi upon 2, pi over 3 divided by 3. It's rho, so rho over 3 divided by 3. And here we have sine phi. Our limit 0 to 4. And we have d phi to theta. Okay, so what do we have here? 0 to 2 pi, 0 to pi upon 2. Okay, now if we say 4 to the power 3, equal to 64 divided by 3. 64 divided by 3 d phi. Okay, I forgot 10 d phi d theta. Okay, here I think I should write sine phi since I haven't integrated with respect to phi. Okay, so now I integrate with respect to phi. So if we integrate sine, we're going to get negative cos. Okay, so from 0 to 2 pi. Okay, so I'm going to have 64 over 3 times negative cos phi. Okay, limits pi is from 0, it's from 0 to pi upon 2, then the theta. Okay, and what is going to happen here? 0 to 2 pi. Okay, and you should know that cos pi upon 2, remember that your calculator should be in radians. Okay, so cos pi upon 2 is equal to 0, and cos 0 is equal to 1. Okay, so that means we're going to have 0 minus 64 over 3 times 1. Okay, to theta. Okay, and then so this is going to 0 2 pi. Okay, 64 over 3 to theta, and if we integrate with respect to theta, we're going to have 64 over 3 theta ranges 0 to 2 pi. And what is going to be our volume? Okay, so if we multiply 64 remainder 3 times 2, we're going to have 128 over 3 pi. That is going to be the volume of our sphere. Problem like this are given the volume bounded, and you should know that this is the volume, this is the equation of a cone. Okay, so you have the bounds for z, divide each and every term by root 3, going to have z equals 2, so this becomes the equation of a cone, and we have the upper bound for z equals to 9. Okay, so you can use cylindrical coordinates or spherical coordinate problem like this. Okay, so I have a video in which I explain how to calculate the volume of a region, which is a cone, okay, using spherical coordinates and cylindrical coordinates. Okay, so all you need to do after watching this video, and just type using both spherical coordinates and cylindrical coordinates in finding the volume of a cone by thinktankonline learning. Okay, you see my video explained using 3 method. Okay, so now I'm going to another different method since I've solved this one. Okay. Okay, so in this problem we're given, I want to find the volume of the solid that lies above. Okay, so by now I think you should know that this is the volume of a cone, and below, so we're given this is the equation of a sphere, but we have a problem here because rho is not equal to a number, it's not a number, it's c. Okay, so that's why I picked this problem. Okay, so I'm going to do this problem. So first of all, I think let me start by sketching the problem that we have. Okay, so if we sketch here, we have a cone. Okay, so this is our cone. Okay, this is our cone. Okay, but we have a cylinder. Okay, Z, Y, or X, this doesn't matter. Okay, so some of you may be shocked why the cone is below this one. Okay, so if we read here, find the volume of the solid that lies above. Okay, so this is above Z, so above Z equals to 0, but it is below something, below this sphere. Okay, so since we're given a sphere, we're going to use spherical coordinates. Okay, so now we want to find phi, want to find theta, and want to find rho. Okay, so the first thing I'm going to do, I'm not sure about rho, so I'm going to first start by rho. I think rho is easier to start with. Okay, so rho, say this is the equation of a sphere, and you know that x squared plus y squared plus c squared equals to rho squared. So I'm going to say rho squared in this case is equals to z, but we've said that z in spherical coordinates is equal to rho cos phi. Okay, so in other words, we're going to say rho squared is equals to rho cos phi. Okay, so that means rho is equals to cos phi. If we divide both sides by rho, okay, now I'm done for rho. Then for phi, okay, before going to phi, what about theta? Okay, I have said that the shadow of a sphere is equal to the shadow of a sphere is going to be a circle. So the angle that will rotate right around the z-axis to cover this region is going to be a circle. Okay, so that means theta ranges from 0 to 2 pi. Okay, now for phi, it is the angle that will rotate around the positive z-axis up to this point. Okay, we're going to calculate it. So we're going to calculate it. I'm thinking using this equation of a cylinder is going to be very easy. So I'm going to remind you, we said x is equals to rho cos theta, sine phi, and said y equals to rho sine phi sine phi sine theta. Okay, so here I have z is equals to x squared plus y squared. Okay, but you know what is z? Z equals to rho cos phi. What happened if I equate this equation to this one? Okay, so if I say z equals to, so for x squared is going to be rho squared cos theta squared sine phi squared. Okay, plus for y squared I'm going to have rho squared sine. Okay, so this is going to be sine phi squared sine theta squared. Okay, and I'm going to use the identity cos squared theta sine squared theta is equal to 1. Okay, so if you factor out rho squared sine squared phi, okay, we're going to have cos theta squared here, sine theta squared here, and we're going to have 1. Okay, so that means we're going to be left inside the square root rho squared sine squared phi. Okay, and what is going to happen, you know, the square root of rho squared is rho sine squared phi is going to be sine phi, and if we solve, if we equate cos phi to rho sine phi, okay, and don't solve for phi, we're going to say cos phi is equals to sine phi, divide both sides by cos phi, I'm going to have the tan inverse of phi, okay, of 1. That means phi is going to be pi upon 4. Okay, so now we have phi, that means phi ranges from 0 to pi upon 4. Okay, so just trying to say this angle is equal to pi upon 4. Okay, and now let's set our triple integral. Okay, so I'm going to have 0 to 2 pi for theta, 0 to pi upon 4 for phi, 0 to, okay, I didn't say anything about rho. Limits for rho. Rho ranges from 0. I'm going to leave it in terms of cos phi. 0 to cos phi. So it's 0 to cos phi for rho. Our Jacobians phi squared, rho squared sine phi d rho d phi d theta. Okay, let me just integrate up to phi. Okay, so we have 0 to 2 pi. Okay, 0 to pi upon 4, and they are going to have pi rho to the power 3 over 3 sine phi. Okay, and the limits for rho 0 to cos phi. Now we have d phi to theta. Okay, and what is going to happen here? We have 0 to 2 pi. Okay, so say if we say upper bound minus lower bound, going to have 0 to pi upon 4. Okay, so this is going to be cos cubed phi sine phi over 3 d phi d theta. And now what we're going to do, want to integrate cos cubed phi sine phi. Okay, so I'm not going to integrate here. If you want to know how you can integrate here, you can check in any of my videos where I integrated. Okay, the video I have told you to watch. Okay, the video of a coin, I think I have integrated something like this. Okay, so now I'm trying to save time. Okay, so if you integrate with respect to phi here, that's that integrate with respect to theta, you're going to get your answer pi upon 8. And now we're going to another problem. Okay, so some of you may be worried about sketching. Okay, so let's say I'm not going to solve this problem without sketching, but I'm going to show you the diagram at the end. Okay, so I want to find the volume of the region below c equals 6 minus x. So I mean this is the top plane. Okay, above this c equals negative. Okay, since this is the equation of a cone. Okay, so no, the equation of a cone normally would be given, we no longer have a positive here. Okay, so if we have a negative, that means our cone opens not in the upward direction, but it opens in the downward direction. Okay, so that means we have something like this. Okay, and it is inside a cylinder. Okay, so what we're actually doing here, I'm not going to draw, but if you are going to draw, you know, you have a cone on the bottom, you have a cylinder. Okay, and we have a plane. Okay, so what I'm going to do here, and you're given a condition x is lesser than 0. Okay, so what we're going to do to find our limits. Okay, so I'm going to draw a circle here. So this is a circle. Okay, this is the y-axis and this is the x-axis. Okay, so I'm going to draw a full circle here. Okay, but we're given that x should not be greater than 0, so we don't need this region which I'm shading. Okay, so now that means our theta ranges from pi upon 2 to this part, which is pi upon 3 pi upon 2, okay, to 70 degrees. Then what about r given that this cylinder is the equation x squared plus y squared, so this circle we have r will be equal to root 3. Okay, so r ranges from 0 to root 3. Okay, then what about z? Okay, so in this problem z, it's obvious this is going to be the lower bound and this is going to be the upper bound. So that means z ranges from this equation negative 4x squared plus 4y squared, or in the square root, okay, to x 6 minus x. Okay, so now as you can see, the limits for z, the same as, okay, so what we're going to do, we know that x squared plus y squared is equals to r squared. So that means we can write this as negative 4 r squared. Okay, and this is equal to negative 2r. Okay, so now I think, what about here? Okay, we said x equals to r cos theta. Okay, so this same as saying 6 minus r cos theta. Okay, so now what if we solve our triple integral 0 to 2 pi for the angle, 0 to root 3 for the radius, then for this, for the z limit, okay, we say the lower bound is negative 2r, then the upper bound is 6 minus r cos theta. Okay, then we're going to have the z for dy dx. It's going to be r d theta. Okay, and now we're going to solve for simple triple integral. So you can see this is how you can write, you can present this one. Okay, there's no need to draw the graph, but if you draw the graph, you see what is going to happen, and you should take note of these limits. Okay, so what we're going to have, if we integrate respect to z, we're going to have, okay, I'm making a mistake here. Okay, instead of writing my limit, it's from pi upon 2 to 3 pi upon 2. Okay, 3 pi upon 2 to pi upon 2. Okay, radius 0 to root 3. Okay, so I'm going to have z 6 minus r cos theta to negative 2r d theta. Okay, don't forget this r. Okay, so our limits from 3 pi, from pi upon 2 to 3 pi upon 2, 0 to root 3. Okay, so upper bound minus lower bound is 6 minus r cos theta plus 2r, and if r d theta. Okay, so what happens if we expand here? I'm going to try it here. So from pi upon 2 to 3 pi upon 2, 0 to root 3, I'm going to have 6r minus r squared cos theta plus 2r squared dr d theta. Okay, so now let's integrate with respect to r. Pi upon 2, 3 pi upon 2. Okay, so I'm going to have 6r squared over 2 minus r cos theta over 3. Okay, plus 2r over 3, and the radius ranges from 0 to root 3, and we have the theta. Okay, and if we simplify, put our limits 3 pi upon 2 here, what we're going to get? Okay, from here I can say this equals to 3 times r squared, and r squared is root 3, so I'm going to have 9. Okay, then here we're going to have r cubed, that is 3 root 3 cubed, so I'm going to have negative 3 root 3 over 3 cos theta, and they are going to have plus 2/3 times 3 root 3, okay, to theta. Okay, so you can see this will cancel, this will cancel. Okay, and now say from pi upon 2 to 3 pi upon 2, going to have 9 minus root 3 cos theta, okay, plus 2 root 3 to theta, and if we integrate respect to theta, we're going to have 9 theta here. Okay, the integral, if we integrate cos theta, we're going to have sine theta, so we're going to say minus root 3 sine theta, and here it's plus 2 root 3 theta. Then our limits from pi upon 2 to 3 pi upon 2, and what is going to be our final answer? So if we integrate, we're going to get approximately 42.6. Okay, so this is what we're going to get. Okay, so don't forget to subscribe. Thank you for watching. I hope you enjoy.